Hi, we are back now with section 4.12, and we left here at the first video where we had drawn the graphs of these three functions. So the functions are 3 to the x, 4 to the x, and 1 over 3 to the x. So notice here that 1 over 3 to the x can also be written as 3 to the negative x, and if you look at the purple one and the green, they are basically reflections of each other over the y-axis. So, and you remember that when we have g of x looks like f of minus x, where f of x is a base function, and this means reflection over the y-axis. So now let's look at the domain, range, and y-intercept and the HA. So in all of these functions, these we call them the basic exponential functions. So the domain will be always negative infinity to infinity. And the range depends, for the basic functions, it will always be 0 to infinity, which tells us also that there is you can see there is a horizontal asymptote, which is the x-axis. So the HA will be y is equal to 0 always, and the y-intercept will always be 0, 1. So again, remember this is for these base functions, just like 2 to the x, 3 to the x, pi to the x, pi to the x, and so on. Okay, now there is another function which is actually called the exponential function. So often when we talk about exponential function, people think of this function, e to the x, but all the others that I just showed you, those are also exponential functions. Now, e is called the e is a number actually which is real, but it is irrational, like pi. So remember, pi is a real number, but it is irrational. So irrational numbers are something that we don't, like in everyday life, we don't encounter them much. But pi, well, you have used it for a long time by now. E is another common irrational number, and its value is like 2.71828, and so on and so on. It never finishes. So people have gone up to like thousands of digits, and they still want to know what is the next digit, and that's how we realize it is an irrational number, because it never stops and no one can guess, or there is not a pattern to tell you that what will be the next number. Okay, so the function f of x is equal to e to the x is the natural exponential function, which is often referred to as the exponential function. Okay. Now note here, if we are going to, for example, graph this function, then we will have to estimate the values or approximate the values. For example, the value of e, which is 2.7182, like the value of pi, it is also an irrational number, so it keeps on going. So when we say 3.14 is pi, that is not exact value, that is an approximation or rounding. This is the value that we get after rounding after two places, two decimal places. If we round at one decimal place, the value will be 3.1. And if we round to 2 or 4 or 5 decimal places, so accordingly, it will have more digits to the right. So here if we approximate this after 2 digits, I hope you guys know how to do the rounding. So if you put a line here, so you look at the number to the right of the line. If the number to the right of the line is 5 or more, well, how big it can go? It can be 5, 6, 7, 8, or 9. That's all. These are the values it can take. So if it is one of these values, we discard the whole, all the numbers after that line that we put, and then we add 1 in the previous digit. So we get 2.72. So we will approximate it like 2.72, but for graphing purposes, we will approximate it to just one decimal place, so 2.7. So E square is 7.39 blah, da, 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 but we are going to approximate it to 7.39, and then from here, we approximate it to 7.4 for graphing purposes. In the same way, 1 over E or E to the negative 1 will be approximated to 0.38, which is for graphing purposes 0.4. So now we have to sketch the graph of f of x is equal to e to the x, f of x, g of x is equal to e to the minus x, and h of x equal to negative of e to the x on the same grid. And then we have to give the range, domain, and all that. Okay, let's start. So the first one, e to the x. So I will have, if I make a table of values for e to the x, so again, remember we are only going to go three points. So at negative 1, the value will be 1 over e, which is, we said 0.4. At 0, value will be 1. At 1, value will be 2.7. So we can plot it. So at 0, the value is 1. At negative 1, it's 0.4. And at 1, it is going to be 2.7. So this is 2.5. So 2.7 is somewhere here. This is the graph of e to the x. So look at that shape, looks very similar to what we just drew in the graph, but this is this grows faster than most of the, like this will grow faster than at least 2 to the x, not faster than 3 to the x, because 3 is bigger than e. And so now this is e to the x. Then we have e to the negative x. So e to the negative x, you know, is going to be the flip of this function over the y-axis. Because if you take the, make the sign chart for this one, make the table of values. So at negative 1, this will give you e. At 0, it's 1. And at 1, it will be 1 over e. So e to the minus 1, which is 1 over e. So that we have the similar graph shifted on the other side. So at negative 1, it's going to be 1. No, it's going to be, sorry, at negative 1, it's going to be e, which is 2.7. At 1, it's going to be 0. At 0, it's going to be 1. At 1, it's going to be 0.4. So this is e to the negative x. So when we have a, remember, a negative sign is attached to x or put in front of x, then what is that? That is a reflection of your function about the y-axis. But if the negative sign is put with the whole function, so remember the first function that we drew was e to the x. So now if you compare this with e to the x, we have just placed a negative sign in front of x. So this will be reflection of e to the x about the y-axis. Okay, and then also we have to graph e to the minus x. So negative e to the x. So what does that do? Negative e to the x. So if you make the values -1, 0, 1, so now what will happen at -1, you will get -1 over e. At 0, it will still be 1, but because of the negative sign, it will be -1 now. At 1, it will become -e, the -2.7. So at 1, at 0, it's -1. At 1, it will be -2.7. 2.5 here and 2.7. And at 1, it will be -0.4. Again, we now combine, join these points, and we get our, wait a minute, yeah. Okay, so if you now notice, this is the reflection of e to the x about the x-axis, which is what it should be, because it says negative of e to the x. So if you notice, this is the reflection of the purple graph, which is the e to the x graph, reflection about the x-axis. Okay, so we call them the basic exponential function. So now we actually define formally define the exponential function. So we say the exponential function with base a. So remember, you already know this, that when you see something like this is the base and that is the exponent. So with base a is defined for all real numbers and is given as f of x is equal to a to the x. Okay. So and we have condition on a that a cannot be a negative number, or a cannot be a 0, and also a cannot be 1. So why, we will see in a minute. But a has to be greater than 0, so a can only have positive values, and then a cannot be 1. Remember, 1 is a positive value, so a cannot be 1. And the reason is, so we said, according to combining these conditions, we have a cannot be 1, a cannot be 0, a cannot be negative. So what happens if we take set a equal to one of these? If a is equal to 1, what does the function look like? Then the function becomes f of x is equal to 1 raised to x. No matter what value of x you choose, you'll get 1. 1 is a constant function, so this is not exponential. And if now we take, if a is equal to 0, you can see the same thing, that your function will become 0 to the x, which is 0, which is not exponential. And what if a is negative? If a is equal to, let's say, -1, simple -1. So what will happen? Your function will become f of x is equal to -1 raised to the power x. Now what will happen if you take the value, make a table of values, right? 1, 2, 3, 4, and so on, like we normally do, and we can take the negative ones as well, but we just want to illustrate or to show that it doesn't work. So if when x is 1, you will get -1. When x is 2, you'll get 1. X is 3, you'll get -1. So it is fluctuating between +1 and -1. So it will not be um, an exponential. It will keep doing this. Okay? So that's why we cannot have these as our a. So the domain is going to always be the all real numbers, and also the range is going to be 0 to 0 to infinity for the simple a to the x type of graph, but if you have a transformation or a flip, then we will have could have different ranges. Domain will still be the. Now note here, this e to the x the e to the x and e to the negative x. We can consider them separately, think of them as two separate function, or we can think of e to the negative x as the flip of e to the x over the y-axis. So that's your choice, how you want to treat it when graphing comes. So the y-intercept will always be 0 to 1 range, and the y is equal to 0 will always be the horizontal asymptote. So the graph, again, we said of a to the x for a greater than 0. So we saw that sometimes we are getting this graph, and that the why. The reason is because when you have on the number line, first thing we said a has to be greater than 0. So means if this is 0, you cannot have 0 but anything here, but also not equal to 1. So we skip these two values, and then everything else a can take on value. Now if a is here in this region, then a is less than 1 but greater than 0. So a is between 0 and 1. In that case, you will get this graph. So if a is a number which is less than 1 but greater than 0, your graph will be this shape like this over here. Now if a is greater than 1, could be any number, then the graph will be like this graph. We now talk about transformations of exponential functions. It works the same way as we have learned the transformations in other functions. For example, square root x function, if you recall, we did a bunch of examples there. So let's look at this one first. So this is f of x is 2 to the x minus 3 minus 1. So we can say that our base function is 2 to the x. So what is the first transformation? This one. So I actually, I would like to do it this way. 2 to the x base function, 2 to the x minus 3. What is that? Shift right 3 units. And then 2 to the x minus 3 minus 1, that is shift down 1 unit. Okay, so you should be able to see this. I mean, we don't need to draw it, but for example, if I say, let's see, this is -1, this will be 2, be 3, -1, -2, and then okay. I didn't draw keep the much space on the left, because remember there is a right shift of 3 units, so I needed space for that, and also because we are shifting down a little bit, so not too much space on the top. So first thing that you should do is, whenever you see a transformed or transformation of an exponential function, the first thing you should see that does the asymptote move. So when will asymptote move? Only when there is a vertical shift. So if we are going up or we are going down, then we will have a shift of the asymptote. So since we have a shift down, so the first thing you should do is graph the asymptote at that level. So one shift of one, so the asymptote will shift 1 unit. Shift down 1 unit. Okay. Now, so our original graph would look like something. It will pass through here. At 1, it will be 2, something like that. Okay. So then we shift it right 1 unit. What happens? All these 3 points, you can actually make a table of values for the first one. So base function, what is your table that goes with that? At -1, it will be 1/2. At 0, it will be 1. And at 1, it will be 2. So at -1 is 1/2, and so on. Now for this shift, those points. So this is when you do this, this is not taking points. Okay, this is still considered as transformation, using transformation, because you use some points just to draw your graph, not the transformation. Okay, transformed graph, not the final graph. These points that we took, these are to draw sketch the basic draw, or to see how the basic draw graph would be. Now you don't need to draw this graph, but if you do it, it's okay. I would suggest do it shaded, or do it very lightly, draw it very lightly, so that it doesn't confuse anyone looking at it with the actual or the final result. Then shift to 1 unit. So what will happen when you shift horizontally? The x values change. Okay, the x values and the y will remain the same. So it's shifting 3 units to the right. So we add 3 to each x value. So when I add 3 to -1, I get 2. And when I add 3 to 0, I get 3, and then 4. So at 2, the value will be 1/2, 1, and 2. So 1/2. 1/2 is over here. Okay. 1/2, and then 2. And then we have to shift down 1 unit. Now when it shifts down, already, can you see when we shifted it right 2 units, 3 units, sorry. Did we shift 3? I shifted it 2. Okay, we have to shift 3 units, not 2 units. Yeah, I think we were right. Okay. So we shifted it 3 units. Let's do it again. Okay, so let's look at it again. So we shift 2 units. So at 2, the value is 1/2. At 3, value will be 1. And at 4, it will be 2. So this is the okay. So you can see now that this is not the y-intercept has changed. The y-intercept has changed. We do not need to find the y-intercept at this stage. Now we have to shift it 1 unit down. So what will happen? All these points that we did, so when we do it down, x remains the same, the y values will change. So we'll subtract 1 from each of the y value. 1/2 minus 1 is 1/2 minus 1 is negative 1/2. 1 minus 1 is 0. And then what else is 2 minus 1 is 1. Okay. So we have, I will draw it with red color, different color. So at 2 will be here. At 3 it will be at 0. And then at 4 it will be at 1. And this is what we were expecting. So now this is clearly showing what the x-intercept is. In this case it's 3, 0. So which is an additional information that we can put. So what is the domain here? Domain is negative infinity to infinity. Range will be, so always remember now wherever your asymptote is. So if your graph is above the asymptote, then the range will be the asymptote from the asymptote to infinity, which is the case we are looking at. So it will be negative 1 to infinity. If your graph is on this side of the asymptote, then it will be minus infinity to negative 1. And then the HA. So now HA has changed. It will be y is equal to negative 1. What about the x-intercept? Well, x-intercept in this case we can say is 3, 0. We can easily tell, but not always, because it will involve logs to find the x-intercept. So now the y-intercept is easy because you just have to set x equal to 0. So y-intercept will be y equals 2 raised to the power 0 minus 3, or 2 to the negative 3 plus minus 1. So 2 to the negative 3 will be 1 over 8 minus 1, or we can say minus 7 over 8. So this is like something very close to 1 but less than negative 1. So that's what we are looking at here. So this is very close to negative 1 but less than negative 1. So we are here. So that is how you graph these exponential functions and their transformation. Okay, we have 2 more here. So what I'm going to do is I will ask you to pause the video here. Try these graphs by writing, on the sides. For example, here you can take your base function. Base function will be 1 over 3 to the x. And then because you have a negative x in the up there, so then you should go with the second one will be the negative x. So this will be the flip over the y-axis, and then you have to add 1 to it. The next one will be, you can look at 1 over 3 raised to negative x plus 1, and then the last one will be the shift over the x-axis, which is putting the negative sign outside the expression. So you can make table for each of them and write the transformation. So the name of that. So this is your base function. So this will be the flip over the y-axis, and so for the base function, your table will be at -1 you have 1/3, or is it 3? Can you see it becomes 3 at -1, and at 0 it will be 1, at 3 it will be 1/3. And then when you come to the next one, which is flip over the y-axis, and accordingly you should be able to see what the table is. And then when you add one here, which is, you have to think about it now, is it shift right or is it shift left? And then accordingly you will have your table, and so on. Then last one, so table, and the table of values for each of them, and then you can graph the final version. So let me give you some time and I'll come back and we will then compare your graphs and my graph. Okay, see you in a bit.